prize. Competition details following the programme.
The Karoo Desert covers 500 square miles in central South Africa. It is an ancient storehouse of prehistoric creatures. Roger Smith has been collecting fossils here for 20 years.
We're driving through the Great Karoo, this vast inland basin which is today exposed as these great expanses of nothingness in the over about 200,000 square kilometers of the central part of South Africa. But we're heading towards some areas where the rocks are well exposed, and we can really get a handle on what was happening when these rocks were being laid down through viewing the geology and the fossils.
For those who know how to read fossils, the Karoo is a way of traveling back in time.
Geological time is, of course, very difficult to handle for most people because it's measured in millions and thousands of millions of years.
On Roger Smith's expeditions, he goes back before the dinosaurs of the Triassic and the Jurassic to the beasts of the Permian.
These life forms were living around 250 million years, whereas the dinosaurs, which people are very familiar with, only evolved around 200 million years. So we're dealing with a period of time at least 50 million years before the dinosaurs.
The Karoo then was very different. Now it's bleached dry by the sun, too arid to support much life. 250 million years ago, it was lush, rich with plants and teeming with exotic beasts.
During the late Permian, something like 260 million years ago, there was a great range of animals, very complex food chains, and in any single place you went in the world, you would have found a range of different plant eaters, several different carnivores feeding on them.
And it was then the most complex ecosystem there had ever been on Earth.
We wouldn't have had a scene of antelope or lots of deer-like creatures. Instead, we would have seen a very large number of creatures living very low to the ground with these large teeth extending out from them. Among them would have been larger herbivores and larger carnivores. But I think The strongest sense we would have gotten is how different it looks from anything today. That's what really strikes me. It was an entirely different type of world.
This distant world lay hidden from us until 20 years ago, a farmer discovered an unusual footprint.
The farmer came across that footprint and saw it was quite unique for the area and picked it up and took it to his farmhouse. But he didn't really understand the significance of it until about 10 years ago, the Geological Survey geologist who was mapping the area came across it and asked the farmer where he'd found it. And the farmer then brought him to this site. And he was amazed by what he saw and alerted me at the museum. And I came out and was absolutely enthralled by the sheer detail.
The footprint is a frozen moment in the Permian, laid down on a riverbank alongside other activity in the time between two floods.
The whole sequence must have occurred over a period of about 8 weeks. That is, from the original flood to the drying up to the impression of the footprints to their burying again by a subsequent flood. 8 weeks in geological time, 8 weeks in the Permian 250 million years ago. 8 weeks, a mere instant in time, preserved like this.
The footprint was made by a therapsid, ancient Greek for arched beast. Although this family of creatures lived 50 million years before the dinosaurs, they were far more advanced than them. Fossils show they were reptiles that were fast evolving into mammals.
In the late Permian of South Africa and Russia, where we know these animals best, there are 3 or 4 major groups of mammal-like reptiles that made up these complex ecosystems. There are small ones about the size of a mouse, through dog-sized ones, right up to some animals about the size of a rhinoceros.
They're halfway between a reptile and a true mammal. Their behavioral characteristics, I think, probably would have been a mix between what we associate with reptiles and what we see with mammals today. It would have just been a sense of great strangeness.
But what's strangest of all is that these creatures are our distant ancestors.
This was the time when the ancestors of the mammals, the hairy animals, including ourselves, really radiated and became very important.
Well, mammal-like reptiles are our distant ancestors. They are the precursors, the first true mammals.
With each new fossil find, paleontologists are discovering more about how mammals evolved from reptiles. Footprints can give a clear insight.
The footprint clearly shows this inward curl on the first 4 digits in towards the midline of the body. That tells us quite a bit about how the animal was walking, because it's really showing a rotation of the foot, the planted foot, in the wet sand. But the 5th digit here is not part of that rotation. So that the interpretation here is that as the foot was placed down on the ground, the thumb went down first, 2nd, 3rd, 4th, and then there was a rotation of the toe, and the 5th digit went down. Now that is classic for an animal which is not an upright gait. It's an elbows out reptilian type of gait, and also the overlap or the near overlap of the hind right foot with the front right foot here shows that it was able to bring its back foot almost into the front footprint, which meant it must have bent its back in a sinuous sort of way. So not only had it elbows out, it also had a swinging gait of the backbone. So that even though these animals were trying to become mammals, they were still pretty much walking like reptiles.
Still reptiles at this time, but the conditions in the Permian were ideal for rapid evolution.
There are conditions under which evolutionary change is quite likely to happen, and there are conditions under which it's really not very likely to happen at all. And the conditions under which for it to happen, you have to get lots of things right. And first of all, you have to have a population of the right sort of size. It really shouldn't be too big, otherwise, you know, or any sort of variation that crops up is likely to be swamped. On the other hand, it shouldn't be too small, because if it's too small, then any change is likely to lead sort of very, very quickly to extinction. So you need a sort of middle-sized population. But within that middle-sized population, you need lots and lots of genetic variation, because if you don't have genetic variation, then there's nothing for natural selection to select among.
With great genetic variation amongst the animals of the Permian, and with many millions competing for limited food and water, only the fittest survived. The places where fossilized therapsids are found indicates just how much of a struggle it was to stay alive.
It appears that animals migrated to this point before they died. That's why there are so many in this area. And the likely scenario is of a shrinking water hole where the animals came to drink, but were drought-stricken. So this is siltstone laid down in those periodic floods. And here, buried within that siltstone, is a complete articulated skeleton. It's a pig-sized herbivore, but it's a good therapsid mammal-like reptile. Here you can see the head of the femur, and the femur sitting here, the tail going through the vertebrae, the backbone here, right curled around here towards the skull, and there's the skull sitting on its side, with its snout pointing in this direction. There's the eye, there's the nostril, and there's the top of the snout. The lower jaw, this big-shaped lower jaw coming up towards the back of the head here. So it's a pretty good specimen.
With strong competition for limited resources, mammalian traits would have aided survival, benefiting the therapsids over the reptiles.
We can distinguish them from other reptiles because they show a number of features that mammals now have, and they show us that these were acquired step by step, and largely during the Permian. So, for example, the Permian mammal-like reptiles, many of them had differentiated teeth. That means they didn't just have uniform peg-like teeth, as all typical reptiles do. So they had incisor teeth, as we do at the front of the mouth. They had long canine teeth, again, as we do. And then they had cheek teeth for chewing at the back. And this was associated with a really major change in their feeding patterns. They had jaws just like our ones that they could rotate, and they could chew. They could move them back and forward, side to side, and chew in a complex way. Whereas typical reptiles simply have a hinge-like jaw apparatus which just opens and shuts like that, and they can't chew their food. They simply gulp it and swallow it whole.
As full skeletons of the therapsids are assembled, paleontologists develop a clear picture of their anatomy and how they moved. But what did these creatures look like? And how did they differ from the reptiles they evolved from? For the first time in a unique collaboration, the beasts of the Permian have been brought to life. 50 million years a world strangely sophisticated for their time. Very few representations of these therapsids exist. So a paleontologist and a model maker have come together to try to reconstruct some of these remarkable creatures.
They had a whole range of different teeth, just like a modern mammal, you know, just like a lion or whatever. These huge canine teeth, and then quite sharp, piercing incisors at the front, and then the teeth in the back of the jaw.
Neil Gorton has worked with Hollywood's biggest names. To build accurate therapsid models, he needs precise details of their anatomy and behavior.
What about coloration? I mean, if they were they always say they could be purple, they could be green, they could be anything because colour never survives. But I mean,
you're right.
What would be a good guess?
You're right. I mean, we would imagine that they would have some kind of camouflage. They might have had a sort of brownish, greenish upper surface and paler undersurface. That's just based on looking at modern animals that...
like a crocodile will be...
Yeah, they sort of blend into the background somehow so that any predator wouldn't spot them from a distance. And
we're all fed that kind of Jurassic Park and when dinosaurs ruled the world, you know, all those kind of movies. So suddenly to find out there's this whole different kind of animal, something that was part mammal, part reptile, just a completely different world.
After 250 million years, the beasts of the Permian can now be seen again. There are known to be about 15 different species of therapsids. Most were herbivores, but at least 3 species were carnivores.
these were not very fast-moving animals, you know, so they were fearsome enough against each other, against us, but they couldn't keep up with a modern antelope, you know. But then the thing they're preying on is even slower and heavier. So.
But they can still do, I mean, it's like a modern-day crocodile can do quite a turn of speed,
That's right.
even though it's a huge beast, you know.
They probably relied on a sort of lunge predation. You know, they would wait for the prey and then leap at it and run at it. But if you could outpace it for 100 yards, you'd be free.
Of all the therapsids, Moschops was the largest, growing to a full 16 feet in length.
Moschops were massive creatures, very strange to our eyes. They had rather heavy bodies and short legs, but huge skulls. And Moschops is unusual in that it's got a very thickened skull roof. Obviously not a very intelligent animal. Why did it have the thickened skull roof? It's believed that perhaps Moschops would have engaged in head-to-head butting of some sort, crashing the heads together. Maybe males fighting for females, of course, the old story.
Moschops was a plant eater with a voracious appetite. It stayed well clear of Ankylosaurus, a vicious carnivore.
Many of these were somewhat dog-like in shape. They had very large canine teeth, which shows they were for piercing flesh and for eating meat.
Ankylosaurus, I think, may have been really one of the more hideous predators in the history on Earth. We are so surrounded by images of dinosaurs as gigantic and monstrous carnivores, but were we to see an Ankylosaurus, I think it would be far more of a shock. This is a cross between a reptile and a mammal. So imagine a large lion that has reptilian characteristics. And you have, I think, a pretty good view of this creature. But very large teeth, not much intelligence, but nevertheless a very powerful and ferocious beast.
Lumbering around the Permian waterholes was the Lystrosaurus. Slow and placid, they eked out a pig-like existence, eating anything they could find. Lystrosaurus
was quite often the size of a pig, but but you get the sense of rather a shuffling, low animal. It's feeding off vegetation low to the ground. It lives in large herds. So a fascinating beast, but certainly it would have never won a beauty contest.
Paleontologists are keen to discover just how mammalian these therapsids really were. Two crucial questions are whether they were warm-blooded and whether they produced live young.
One of the mysteries we haven't yet solved is whether the therapsids as a group actually laid eggs or bore live young.
If some of them gave birth to live young, it would open some other options for them. It allows them to have different ways of looking after the young and protecting them. Because if you lay eggs in a hole in the ground or in a nest or something like that, then they're at the mercy of predators and so on. If you retain them inside your body, then you can protect them that way.
In all the world's fossil sites, not a single therapsid egg has ever been found, suggesting they do produce live young. But the only proof would be the discovery of a pregnant therapsid, and again, none has been found. So can we be sure that therapsids were partly mammal? Here at Washington University, a research project reveals that, like all mammals, therapsids were probably warm-blooded. Paleontologist Pete Ward had long wanted to know what the bone structure was inside this baby therapsid's head.
All mammals have a series of very thin bones called turbinate bones. These turbinate bones are found in the nasal passages. What they do is they warm air when it comes into us. If you're in a cold climate or any place where it's cold at all, you don't want cold air cooling your blood, so you build these turbinate bones. So one of the things we can do is examine the fossils of these creatures and look for these turbinate bones. And that would be a very strong clue that indeed these, if not mammals, are certainly on the grade to becoming good mammals.
After months of waiting, Pete Ward has an important appointment at the local hospital. He has been given an hour on the CAT scan to investigate his fossil.
Well, the reason we just don't smash it open and look for these is that, in general, these are very subtle differences in the bone, and breaking it open may not reveal them. However, the CAT scan should pick up these differences, and in this way, we don't have to break an extremely valuable fossil and still get the information.
To see the bone structure, the CAT scan is increased to maximum intensity. The first results are a breakthrough. They suggest that therapsids did have turbinate bones.
What we're seeing here is some evidence that the turbinals did exist. It's almost impossible to see the actual bones themselves. They're made of cartilage, and that never preserves in the fossil record. But you can see here a contact where these turbinals were actually embedded into the bone, and that's what preserves, and that's an indication it's a warm-blooded animal.
The transition from cold-blooded reptiles to warm-blooded mammals was rapid, partly because of constant changes in climate.
You had conditions that were changing rapidly on Earth, and animals and plants really had to increase the pace of their race to keep adapted to those conditions.
But just as the pace of evolution was reaching its peak, disaster struck. Vast numbers of animals were wiped out.
It was an extraordinary time. This mass extinction was the greatest of all mass extinctions in the history of the Earth, and it was not just conditions increasing more of the same. Something horrible happened to the Earth.
The effect was really dramatic. All of these complex and advanced mammal-like reptiles pretty well disappeared, so that what had been a complex ecosystem with small, medium, and large herbivores, small, medium, and large carnivores was cut right down.
As the beasts lay dying at the transition of the Permian and Triassic periods, evolution of life on Earth was put in jeopardy.
I think really the most dangerous moment in the history of humanity, strange as it may seem, happened 250 million years ago. The greatest mass extinction in the history of Earth happens. The number of mammal-like reptiles, our ancestors, dwindles almost to nothingness. If the last of them goes extinct, no mammals exist. If no mammals exist, humans never evolve. So they are an absolutely important and perhaps the most dangerous of links in our long history, dangerous in the sense that were this link broken at that time, no humanity.
The fossils from the time of this mass extinction show the Earth was rapidly heating up.
The fact that we're finding these things rolled into tight balls in sedimentary structures suggestive of burrows indicates to me that this animal is burrowing into the ground, probably because of stress. I suspect heat stress.
Vast swathes of land were bleached dry. The Earth was becoming a desert.
The climate did become more and more arid. We start to see much more drought effects on the animals, the skeletons themselves forming these drought accumulations. And eventually, towards the end of the 200 million years ago, we have clear evidence of desert-like conditions where everything was getting very hot and dry rather than sort of warm and dry.
It wasn't just life on land that perished. Something catastrophic also happened in the seas.
We have record that about 90% of all species in the oceans go extinct as well as on land and at the same time as on land. That's what makes this mass extinction so mysterious.
So what caused this extreme heating effect on land and the mysterious Holocaust in the seas? One theory is an asteroid hit Earth.
The reasons for the end Permian extinction are quite hard to pin down at the moment. People had looked for evidence of an impact, some evidence that a great asteroid had hit the Earth, but that has not really been demonstrated very successfully. The other view is that there was huge volcanism, that there were enormous eruptions in Siberia, great areas of Siberia, something the size of Western Europe, covered by basalt lava.
But carbon dating of therapsid fossils shows the extinction happened over a long period.
We found that the carbon isotope occurs over 10 or 15 meters of section, and that suggests that the duration of the event was on the order of 100,000 years.
Too long to be explained by volcanic eruption or an asteroid impact. So what did cause the massive heating effect? Scientists now think the answer lies in the gradual movement of the Earth's continents and the natural greenhouse gases this produced.
It used to be thought that obviously the continents are static. I mean, what could be more static than a great chunk of land? In fact, it's now clear that the continental rock sort of sits on top of the rock underneath, almost like scum on the surface of a pond. And one can imagine that the pond is actually quite hot and is moving, therefore, with convection currents, and the scum floats on the top. And the continents are the scum, and they keep floating round and hitting each other and breaking apart.
About 450 million years ago, the continents began moving towards each other. By 350 million years ago, they began forming a single landmass, Pangaea. Vast areas lost the coastline that had kept them cool and began to heat up.
When you form a single supercontinent, you create a vast inland desert area, which perhaps is not friendly to life at all.
As the land heated up, so too did the atmosphere and the seas. Tony Hallam has studied the heating effect on the oceans. He believes that a rise in temperature caused enormous deposits of limestone on the seabed to dissolve, producing carbonic acid. This poisoned the waters, depriving them of oxygen throughout the end of the Permian and into the Triassic.
We have clear evidence from the rocks and from the fossils that we had pretty stagnant conditions in the earliest Triassic right across the world. And lack of oxygen is pretty devastating for the vast majority of organisms, and it's a very good wipeout, very good kill mechanism.
In the seas, creatures which have skeletons begin to die off in large numbers. The reefs die, sponges die. It's a mass extinction.
The carbonic acid evaporated from the seas, filling the atmosphere with carbon dioxide. The Earth was hit by the greenhouse effect.
More carbon dioxide goes into the atmosphere. That produces more heat. And the net effect of that is mass extinction through heating.
There had never been anything like it. Tide of death from the sea. A drying up of life on land. Almost all animals perished. But the Lystrosaurus, the prehistoric pig, survived, and with no animals to challenge them, pigs would rule the world. The Lystrosaurus survived the mass extinction, along with a handful of tiny reptiles.
The survivors were few and far between, and as far as we can tell looking at them, there's no way you could have told which animals would survive and which would not. The only animal you find in abundance is the Lystrosaurus.
For the first time in this species' lifetime, it was free of predators.
It's really quite extraordinary. In the history of the Earth, animals always have predators. Even predators have predators. Only in several instances have there been large masses of animals with no predators. Lystrosaurus is one of these. No predators. All its predators were killed off in the mass extinction.
And where you find them, you don't find one or two, you find hundreds of them, so that they dominated the faunas. And it's a very unusual situation in nature to have one species representing 90% or more of the organisms you find.
But why did the Lystrosaurus flourish when other animals perished?
Lystrosaurus survives for one of several possibilities. First of all, it just happened to be one of the luckiest creatures on Earth. There's always that. It's just dumb luck. Secondly, it had adaptations allowing it to survive. The possibilities of this are that perhaps it could burrow, perhaps it had a food source that allowed it to survive under conditions where there's very little food around in terms of plants, because plants go extinct in this mass extinction as well. And Lystrosaurus may have been adapted to one or two plant sources which themselves do not disappear.
Roger Smith is convinced there is one overriding reason why the Lystrosaurus survived the extinction. Its pig-like snout.
It's distinctive in its shovel-shaped, downward-projecting snout. It's got this extremely long snout. And the so-called broken nose syndrome, that in the fossil evidence, always the nose is broken, the snout is broken.
But far from being a physical defect, the apparently broken nose was the key to the Lystrosaurus's success. Close examination shows the nose was part of a flexible, fleshy snout, enabling the Lystrosaurus to munch plant matter in crevices that other animals couldn't reach.
Lystrosaurus was able to survive because it was dry adapted. Basically, it had been living on the more drought-stricken areas around the flood basin. That's where it had evolved, and its particularly unique biting mechanism allowed it to be able to chomp off the more drought-resistant flora that then invaded the basin. Lystrosaurus had been hanging in the wings for most of the latest part of the Permian, and when it saw an opportunity, it took the gap, so to speak.
Over the next 10 million years, they roamed the Earth, gradually becoming more rodent-like. The tiny reptiles that also survived the mass extinction grew larger, eventually developing into the dinosaurs. By the time of the dinosaurs, the Lystrosaurus had evolved into a rodent, later beginning the long transition into squirrels, lemurs, monkeys, apes, then humans.
Mammal-like reptiles are our distant ancestors. They are the precursors, the first true mammals. And had every one of these mammal-like reptiles gone extinct at the end of the Permian, you and I and no human in this room or seeing this program would exist.
The mass extinction that destroyed almost all the life on Earth is only one of 5 similar events. The last one wiped out the dinosaurs. Scientists like Robert May are now taking a fresh look at these catastrophes because they fear the world is in the grip of another similar mass extinction.
Well, there are all manner of extinction events in the fossil record, some big, some little, but there are 5 what we call the big extinctions, the things that took away from us anywhere between 80 or 90% or more of all the species that were alive on Earth at that time. Question is, are we standing on the breaking tip of a wave of the great 6th extinction of a similar size and scale?
It does appear that the rate of extinction at the moment is greater than the rate of origination. And it's possibly in the order of magnitude of that of the end Permian extinction, that is the rate of extinction. So we could learn from our end Permian extinction that this could well be on the way to becoming a mass extinction and of that sort of proportion.
Modern-day extinction estimates are that many thousands of species go extinct every year, indicating that the extinction rate is highly elevated now as compared to the rest of geological time. So I think we are in the middle of a tragedy.
To assess the extent of this tragedy, scientists have looked for a laboratory of life, a self-contained environment to count the loss of biodiversity. Most widely researched is the island of Madagascar.
Something like 100 million years ago, during the age of the dinosaurs, Madagascar was still attached to the side of Africa, and it shared all the same dinosaurs and the other creatures of the time. Then at that point, 100 million years ago, Madagascar seemingly broke away, became an island, and it's remained an island ever since, which is why today it has a very unique assemblage of plants and animals.
Now an extensive project is underway to quantify the number of plants and animals that are disappearing or have already gone extinct. Already the findings are shocking. 3 species of bear and 2 species of hippopotamus have been wiped out, and another 125 birds and mammals are on the brink of extinction. 100 years ago, tens of thousands of these plowshare tortoises lived on the island. Now there are only about 200 of them. Poor vegetation means these remaining tortoises are no longer growing as large as previous generations.
Longueur du carapace, 375 mm.
The conclusion of the survey is dramatic. The rate of extinction in Madagascar is even greater than that at the end of the Permian. The cause this time is, of course, man. As he moved from the coastal areas to the interior, vast areas of forest were destroyed.
We've had a dramatic loss of forest, and all the lemurs and nearly all the faunal all the biodiversity of Madagascar is concentrated in forests, and now forests cover only about 25% of the country.
Because of the wide deforestation, Madagascar's lemurs have been particularly hard hit.
We know that there are at least 15 species of lemurs that have become extinct within the last 2,000 years. So it's really quite recent. This is a brown lemur, it's in English, hello, and not a very exciting name. He's tame because he was found as a young animal. Maybe his parents had been hunted and he was looked after as a very young animal. And he's now not frightened of humans, as you can see, but he doesn't get on with he can't live in a group with other lemurs. I mean, there are other lemurs of the same species in the area, and he gets attacked by them. But he has his own territory, which is this forestry station, but there's no way he can really live in the wild anymore.
If you look back through history, you can see that humans, we have wiped out many, many species. Something like 2 or 3 species of bird and mammal disappearing every year or so. We all know examples like dodos and the passenger pigeon and the great flightless birds of New Zealand. If you calculate from this rate of loss, you might work out that all birds and all mammals on Earth will have disappeared within a few thousand years as a result of human activity. And many people then would interpret that to mean we are definitely in an extinction event as big as any of the big 5 in the past, and that this one is unique because it's being caused by human activity.
It's not only the destruction of forests that causes concern. Many scientists also fear a drastic rise in temperature. The extreme heat that eventually led to the Permian mass extinction began with the movement of continents and was boosted by the Earth's natural release of greenhouse gases. Today, man is producing greenhouse gases on a major scale. And like the Permian mass extinction, the heating effect could be catastrophic for life on Earth.
I believe that what we are doing to the atmosphere, creating greenhouse gas emissions, is in every way comparable to what happened at the end of the Permian. The end Permian event is, to me, in my mind, a greenhouse event. It is caused by excess CO2. We, industrialized humans, are doing the exact same thing to the atmosphere. By 2300 or 2400, so we're looking 300 or 400 years from now, we may have as much as 60% of all species on Earth today extinct.
This sounds like the end of life as we know it. But for the future of evolution of life on Earth, it might not be such a tragedy. For some scientists, like Colin Tudge, mass extinctions are not only unavoidable, but essential.
Mass extinction is absolutely fundamental, I think, to the history of life on Earth. Because Darwin had the idea in the mid-19th century that so long as you had competition between creatures, then you would get change occurring little by little, effectively forever. You know, the predators would gradually get sharper teeth, and the prey animals would learn to run faster, and then the predators would get even sharper teeth, and so on and so on. So they would go on changing. And now it seems to be fairly clear that actually if conditions don't change, then sooner or later, in fact probably quite quickly, the different creatures that are competing in any one ecosystem just sort of settle down with each other, and they stay much the same, more or less indefinitely. And it's become sort of fairly clear that things do settle down in that way, and unless you every now and again you had these huge extinctions, then evolution would have stopped, and you know we would still be amphibians, or we would still be invertebrates, or whatever, and creatures like us would never have appeared. Because every now and again you just have to kick the system, you just have to clear the stage, and just start again with a few of the creatures that were there before, re-evolving to fill all the niches.
So could humans be victims of the current mass extinction, this evolutionary clean-out?
Humans probably would survive, because one of the factors that helps species to survive is to be abundant, but especially to be widespread. And humans, amongst the various species on Earth, are immensely widespread from poles to equators. So yes, indeed, whatever crisis happens, humans are very likely to survive.
Well, if you love humans, as I do, the worst case is that we could go extinct, but I don't think that will happen. I believe humans are the least endangered species on the planet. And that's I think, maybe the great curse, is that we may end up 1,000 years from now, like Lystrosaurs, in a very empty world.
But it's not clear that humans could withstand all global disasters. If the Earth was hit by an asteroid like the one that wiped out the dinosaurs, it's far from certain that we would survive.
Well, humans may be pretty good survivors, and of course humans, like cockroaches, would survive all kinds of climatic changes and other sorts of crises. But some of the big crises that have caused mass extinctions in the past could very well wipe out humans as well, so that if you think of the massive volcanism or some of these huge asteroid impacts on the Earth, humans there would really suffer badly. You couldn't just devise a bit of technology to avoid it. It's not just like the greenhouse effect that we're seeing at the moment, which we can survive.
Humankind often regards themselves as some sort of pinnacle of evolution, some sort of end product, as if there was some sort of guiding force putting them there. It, of course, cannot be true, because we can see the steps that it took to get to humankind. And humankind, of course, is as imperfect as all those steps that it took. To regard humankind as some sort of great survivor, as opposed to anything else on the Earth at the moment, is irrational.
If humans were wiped out in a mass extinction, would anything else replace us? Just as the Lystrosaurus was the unlikely survivor of the Permian mass extinction, so too the survivor species of a future extinction is hard to predict.
If you remove humans from the planet, we're like a big brake on a big car, and we are the brake on those wheels. As soon as we are removed, the car takes off, and that car is evolution. The rate of evolution has been slowed on this planet because humans are holding it down. You remove us, that brake is removed, and there's opportunity.
So if Homo sapiens became extinct, anything could happen. We might even be succeeded by animals less developed than us. The dinosaurs which followed the therapsids were grander in scale, but almost certainly less advanced. The lesson is that evolution is not logical, and its outcome is hard to predict.
I think one thing people don't understand is that evolution does not go in a direct line, you know, from the beginning of life on through to the present day. But in fact, there have been many stops and starts. Life is diversified, then there are mass extinction events which wipe out a lot of life, and then it starts up again, often in a somewhat different direction.
If humans left, I suspect we would see a world that is absolutely inundated and covered by rodents. With the disappearance of humans, you would find rodents and rodent-like creatures, in terms of the mammals, taking over the world. And that's not a vision that I particularly want to see.
And if, in amongst the rodents, there's a small group of human survivors, what would their future hold?
But supposing there was some kind of catastrophe, let's say another asteroid or some ecological collapse, and human beings became isolated into smaller populations on different sort of islands, like Madagascar, for example, which is just about the right sort of size, then we have the conditions in which evolution might start to happen all over again. But would there in fact be a premium on brains? In other words, would natural selection favour further braininess? Well, there's reasons for thinking it might not. I mean, one of the things is that brains are tremendously expensive organs. They take about 20% of all our metabolic energy. So unless the brain was giving you a good payoff in terms of extra food, it wouldn't be favoured by natural selection. And one could see that instead qualities such as muscularity or agility might be favoured instead. In other words, human beings in future evolutionary time could, under those circumstances, become more ape-like again, rather than becoming brainier.
Following the Permian mass extinction, the Lystrosaurus survived for 10 million years before it began to vanish from the fossil records. If the pattern of human existence is anything like that of the Lystrosaurus, at least we can expect to be around for 10 million years.
If you can answer the question, what was the name of the biggest therapsid, you could win one of the animatronics models featured in the programme. The number is 0891 88 1290. Calls will cost no more than 75 pence, and lines are open until the end of the month. Next week, Equinox looks at why the condition of autism may throw new light on male and female relationships. That's next Monday here on 4 at 9. What's your home worth? 40, 50 grand or more? If you live in a new house, you could be in for a shock, because you may find your house guarantee is useless, and that your home is worth a lot less than you think. How safe is a new house? Dispatches, Thursday at 9 on 4. Fitz continues